Hello, this is the third lesson on modular arithmetic. So today I'm going to share some of the results that I found when I was doing this. So of course you might have tried some different numbers and found some slightly different things, but here's just an example of what you could have found. So to start with, I'm going to start by looking at modulo 2. So mod 2. So when doing this, I found that this pattern repeats every 3 numbers. So it goes 0, 1, 1, 0, 1, 1, 0, 1, 1, and so on. So another cool thing that you might have noticed is that every time there's a 0, that means that this number is a multiple of 2. And that's because when a number is a multiple of 2 and you divide it by 2, the remainder is always going to be 0. So 0, 2, 8, 34, and 144 are all multiples of 2, and they all have a remainder of 0. So now a cool thing is, so if our pattern repeats every 3, and we've got 0, 1, 1, one of these numbers is a 0, and like I just said, if it's a 0, that means it's a multiple of 2. So what this can mean is that if 1 out of every 3 numbers is a 0, or a multiple of 2, then 1/3 of the Fibonacci numbers are even. So if this pattern carries on forever and ever, 1/3 of these numbers is always going to be even. Cool. So now let's have a look at what happens during modulo 3. So we've got mod 3. So in this case, looking at my table, you might be able to see that this repeats every 8 numbers. Every 8. 1, 2, 3, 4, 5, 6, 7, 8. So again, something really cool is, every time there's a 0, it means there's a multiple of 3. So 0, 3, 21, and 144, all multiples of 3. And again, that's because if you divide by 3 and your number's a multiple of 3, your remainder is going to be 0. So out of 8 numbers in this pattern, so out of 8, 2 of them are zeros. So 2 out of 8 are zeros, which means that 2 out of 8 are multiples of 3, and 2 out of 8 is the same as a quarter. So 1/4 of the Fibonacci numbers are multiples of 3. Which is pretty cool. So now let's have a look at mod 5, modulo 5. So in this case, it took me ages before I could find a pattern, so I had to extend my table and keep it going. And I found that in the end, this pattern repeats every 20 numbers. So let me see if I can draw that. So down here. Every 20 numbers. And once again, every time there's a 0, it's a multiple of 5. So out of 20, how many zeros do we have? Well, if you count, you can see that there's 4 numbers that are 0. So 4 out of 20 of these numbers are multiples of 5. And 420, yes, 20, 4 out of 20 is the same as 1/5. So 1/5 of these numbers are multiples of 5, which is cool. I can't spell multiples. Multiples of 5. Awesome. So now quickly let's look at modulo 11. So of course you might have looked at different numbers and that's completely fine. So modulo 11. So in this case, I found that the numbers repeat every 10. So this is the pattern here. And like we've just talked about, every time there's a 0, this is going to be a multiple of 11. So out of 10, how many multiples of 11 do we have? Well, there's only one 0, so 1/10 of these numbers is going to be a multiple of 11. So I hope you had fun doing this investigation, and I hope you found some cool and interesting things.